Hey, Mr. Grassetti, what are you doing?
Hi, Mr. Banis. I'm standing here looking at this screen and I'm thinking about elasticity and what that actually means.
You know what's amazing? I've been thinking about elasticity all night.
No kidding.
Great minds must think alike.
They must.
Okay.
They must listen.
So let's talk about elasticity.
All right.
This was not on purpose. Okay. You might have to help me out. There we go.
There we go.
Okay.
All right. Well, we know that, or we should know from our reading that elasticity is the extent to which changes in price affect changes in the quantity demanded.
So if something has elastic demand, a relatively small change in price will result in a relatively large change in the quantity demanded. So our behavior to changes in price is a drastic change as opposed to a small change.
Conversely, if something has inelastic demand, that proportion is much smaller. The change in price causes a relatively smaller change in demand.
If something has unit elastic demand, and this tends to happen only on small parts of demand curves, then a change in price will result in a directly proportional change in demand. Okay, so now we're going to look at some of the factors in elasticity. The first factor, can the purchase be delayed? Is this something that we can put off till tomorrow, next week, next month? There we go.
If, in fact, that the purchase can be delayed, then likelihood is that you have elastic demand. Conversely, if it's something you can't wait to purchase, then it's going to be inelastic.
Exactly. If there are adequate substitutes available, so if the price changes for a good, say for instance the price goes up for a good, if you can find a substitute that will work for that product, you're going to buy that instead. So if there are adequate substitutes available, you will have elastic demand. If, however, it's a good where there are no substitutes, you're going to have inelastic demand.
Finally, does the purchase use a large portion of your income? In other words, you're just the amount of money that you have to spend on a good, are you going to use a lot of it in order to make this purchase? If you are, then it's likely that your product's going to have elastic demand, and if you're not, it's probably going to be inelastic.
Right. So if you took a large item, like say a $30,000 car, and there was a 10% price increase, you'd be looking at a $3,000 price increase. $3,000 is a lot of money, especially the guys like us who wear shirts like this.
That's right.
But if it's $1 coffee, and you go in and they say, hey, Mr. Grassetti, your coffee's $1.10 today, are you really going to mind?
Not at all.
Not really. So he'll still buy the coffee because the price is so low that the 10% change really doesn't bother him at all. Okay, so now what we have here is kind of a matrix that'll help us to figure out whether a demand curve is elastic or inelastic. And the way we're going to do that is with something called the total revenue test. Most of the time we call it a total revenue test, but really that fits more for the supply side. Technically what we'll be looking at today is a total expenditures test, but we're going to kind of ignore that because it basically comes out to the same thing. And I believe the AP exam is only going to say total revenue, so that's what we're going to stick with. So if you look here, what we have is this matrix where on the top we have elastic, inelastic, or unit elastic. And then what we're going to be looking at is a change in price. And this is simply an upward or downward change. For our purposes today, they're all going to be downward changes. So every price that we're going to look at, we're going to start at a high price and move down to a lower price.
Well, what you're telling me, Mr. Banis, is that it could be, we could have to work with a problem that has an upward change in price.
Absolutely.
And the principles are the same.
Exactly the same. Really what we're looking for is whether or not the arrows that are going to come up on the bottom go in the same direction as these, opposite direction, or if they don't move at all. So, for instance, let's take a look at our first example. In this case, we've told you we have elastic demand. Now, Mr. Grassetti, what about this graph's a dead giveaway that we're probably looking at elastic demand?
Well, we're looking at a flatter curve.
Exactly.
Okay? And in a flatter curve, we're going to notice that the change in price over time is going to be
Exactly.
right.
So, if we have a price of $4, what is our total revenue going to be?
Well, we know that our total revenue is going to be the price times the quantity. 4 times 1, it's going to be 4.
Exactly. So our total revenue for a price of $4 is $4. On the other hand, if we drop the price down to $1, we're now going to demand a quantity of 6. So what will our total revenue be now?
Well, once again, it would be the area of this rectangle, it would be $6.
Right. So what we know is that a downward shift in price has resulted in an upward shift in total revenue. So if we go back to our matrix, what we'll find is that when curves are elastic, a downward change in price results in an upward change in total revenue. So what does that tell us, Mr. C, about an upward change in price? What would happen to our total revenue?
Well, what you'd see with an upward change in price is that you would see a downward change in revenue.
Right, because when the arrows move opposite of one another, we know it's elastic. Some examples of things that have elastic demand curves are butter, coffee, jewelry, and peas, particularly easy peas.
I heard easy peas are the most delicious.
Easy
kind of
peas are delicious.
Yes.
Okay, so Mr. C, why don't you take this one?
Well, you'll notice that with this curve, with an inelastic demand, the curve is much steeper. So you're going to see that change in revenue move in the same direction as you change in demand. You'll notice, there we go, that initially at $4, with a demand of 1, our total revenue is $4. And then, if we shift the price to $1, we notice the demand is only 3, and our revenue is $3. So as the price has gone down, the total revenue has gone down as well. Therefore, if we go back to our matrix, what we notice for inelastic demand
There we go.
is that the change in price and the change in total revenue move in the same direction.
Okay, so for our final example, we're going to be looking at a unit elastic demand
Well, hold
curve.
on. Do we have examples of inelastic demand?
Oh, I believe we do.
Do we?
I believe,
Oh,
yes, we do.
we
I'm
do.
sorry.
Yeah,
Got ahead
all
of
right.
myself.
That's all right. Some examples of this would be salt, pepper, a kidney transplant, and gasoline.
Why would a kidney transplant be considered so inelastic?
Well, because as the price of a kidney transplant, which is a very expensive operation, you're using a large proportion of your income,
Right.
even as that goes down, the total revenue of what is being taken in is going to go down as well.
Sure, but I mean, if we think about this even on a more basic level, can I use something other than a human kidney for my own kidney?
No, you can't.
Not for very long.
You need a kidney.
You got to have that kidney, okay? Same thing with gasoline. I mean, you could try to put other things in the engine of your car if the price of gas goes too high, but that's not going to work out very well for you. So one of the things we want to keep in mind when we look at elasticity of different goods and services really is those first 3 questions, right? So can we substitute this?
Nope,
No.
can't substitute a kidney.
Can we put it off for very long?
Not really.
Not really. Is this a big part of our income? Yeah, it is. But 2 out of the 3 questions tell us that it's inelastic, so therefore it's likely inelastic. Okay, so now we'll look at unit elasticity.
Now, if you'll notice in unit elasticity, the slope is almost a 1 for 1.
Yeah.
Okay, and that's how you know that the proportion or the percentage change is going to be the same. So you notice once again, $4 revenue there. We notice as the change in price here is also $4. There you go. You have what's called unit elastic.
Right, so the slope for this demand curve is going to be -1. And we'll get into a little bit more of that in a minute. But if we go back to our matrix, what we should see then is regardless of the movement of this arrow, there will be no change in revenue. So whether the price goes up or down, revenue will stay the same.
What would be some examples of that?
I don't think we have any, Mr.
Oh,
C.
no.
No,
That's
because,
all right.
you know, generally speaking, we'll get more to this later, but the part of a demand curve that's unit elastic is like, it's like
Typically
that.
very small.
Yeah. So, and we'll talk about what that means later on. So just to kind of take this idea to its greatest extreme, if we looked at a demand curve that was perfectly elastic, okay, basically what this means is that regardless of how many we demand, the price is always going to stay $1. So if as a market we want to buy 1 of these, it's going to be $1. If we want to buy 5 of these, it's going to be $1. It really doesn't matter. And there aren't a whole lot of things that are perfectly elastic, but what economists tend to do is we look at things like commodities. And so things like corn, pig bellies, which is what we make bacon from, wheat. And basically the reason for this is, and we'll see more about this when it comes to the elasticity of supply, these products tend to be identical, right? So one farmer's corn is the same as another farmer's corn, and they're ubiquitous. There's so much of it that nobody can really have any control over the price. So the price is going to be set by the market, and that's going to be what it is. So we don't spend a whole lot of time talking about perfect elasticity, but it's an important concept to bring up.
Conversely, with perfectly inelastic products, you're going to see, eventually, keep tapping, there you go, a straight up and down curve, so that we know that there's only this amount of product in the market. There's 5. Regardless of whether that product costs $1, $5, $6, there's only 5 available. It's your ultimate limited resource market.
Right, and if we were looking at this in terms of an individual's demand curve, what this is telling us is that regardless of the price, they're going to buy 5 of this product. So if the price is $1, they're going to buy 5. If it goes up to $6, they're going to buy 5. And really, if we continue this all the way up, for $1 million, they're going to buy 5. Okay, obviously, there's going to be a breaking point there, but we don't have to worry too much about that. So, some examples.
Products that become absolute needs, that regardless of the price you're going to buy, whether it's for legitimate health reasons like insulin, or in the Northeast especially, heating your home, or if it's a need that you've developed as an addiction, whether it's heroin, crack. This is Mr. White, he used to teach chemistry here at Maloney.
That's right.
And so any of these products, regardless of what the cost is going to be, you're going to find a way to want to buy them.
Right, and generally speaking, what we're talking about here are things that, that are necessities that can't be substituted for. Okay, so another example of this would be Heinz ketchup, because it doesn't matter how much Heinz ketchup costs, no one is ever going to buy Heinz ketchup.
There's no ketchup other than Heinz
There's
ketchup.
one, yes.
I don't know why we would even bring that up as a discussion topic.
Well, at this point, you would think everyone would know, but you'd be surprised.
Well, you would think. I don't know what you're eating on the east side of town.
Well, you know, the streets are paved in gold over here, but there still are Hunt's families. Okay, so the next part we're going to look at is the more mathematical end of things. And what is this one called? Is this the ratio?
This is the ratio.
This is the ratio price elasticity of demand. So why don't you go ahead and break that down for us?
Well, with the ratio method, or the price elasticity and demand, what you're looking for is really a change in quantity over the percent change in price. Okay, and what that's going to do is it's going to give you a numerical value toward your elasticity. So what we have to do when we're solving this is we're going to have to change, the percent change in quantity demanded over the percent change in the price, which means we're going to have to figure out percents as well. Q2 minus Q1 divided by that Q1 is going to give us a percentage change. We can express that percentage as a decimal, but it's still got to be the percentage change.
So now what's that triangle all about?
Triangle is Greek for delta. It's not just a fraternity, it is also the mathematical use for change.
Now you were a lambda, 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 correct?
Not me.
No?
No.
I was an alpha, beta. All right,
there you go.
Moving on. So, how about the percentage change in price?
So same concept here. Percentage change in price, second price minus the first price over the first price is going to give you that percentage change.
So once I figure these two out, what do I do with them?
Well, you're going to divide. You're going to divide percent change quantity demanded by the percent change quantity price, and you're going to come up with a number.
And what if that number's negative?
Shouldn't matter.
I'm going to ignore that.
You're going to ignore that.
Okay, because I'm looking for this number,
right,
the price elasticity of demand at the end of it, right? We're looking for just any number.
We're looking for a number, right.
And it needs to be, so just assume that you're using absolute value, okay? Because for the elasticity of demand, it's going to come out negative, which will screw you up if you think too much about it, so just ignore it. We get to supply, it's a little more clear, and then it'll always be a positive number. So for now, if you don't come out with a negative number, you're probably doing it wrong, but we're just going to kind of ignore that, all right? So let's move on, maybe to a quick example.
So if we're computing the price elasticity of demand,
Okay.
we're going to assume our little problem here. Price of an ice cream cone increases from $2 to $2.20. So price 1 is $2, price 2 is $2.20. The amount you buy falls from 10 to 8. Okay. Cones, then your elasticity of demand would be as follows. See, we calculated our percentage here. Okay. Q1 minus Q2 over Q1 times 100, and we get a 20% change. Same thing down here. P2 minus P1 over P1 times 100, we get a 10% change here. Mm-hmm. So what happens when we divide those two is we get a number 2.
2. In this case, we have 2. So this is going to, and we'll get to this at the end, this number is important. This is called our coefficient. And we want to keep this in mind because this is going to tell us whether the curve is elastic or not. Okay. So as far as calculating elasticity goes, the first example we gave you using the total revenues test is a great way to take a quick look at a curve. It'll let us know, like, hey, this is elastic or it's not, or it's inelastic, but it doesn't really give us an idea about how elastic or inelastic it is. The second example we gave you gives us a little bit closer snapshot, right? It kind of tells us, this curve is way elastic or way inelastic, but it doesn't tell us exactly how much. The last thing we're going to teach you is the midpoint formula, which is a little bit more accurate, and it gives us an idea about just how elastic a curve is.
And if you're really into the mathematical accuracy, and all of my economics students know how mathematical I am,
Yes.
this is going to be the one you want to use. This will be the most accurate of all the methods.
Absolutely. Not only that, but you'll see on the AP exam that they will ask you to use a specific method for given questions. So we really do want to make sure that we have all three of these cold. Okay. Let's see. I think we have an example. Okay. So the price elasticity of demand formula is a little bit more complicated the midpoint formula is a little more complicated than the last one we looked at. So you'll be looking at Q2 minus Q1 over Q2 plus Q1 divided by 2. All of that divided by P2 minus P1 over P2 plus P1 divided by 2. So again, guys, it's a pain, but it's something we got to learn. We got to know.
So if we come up with the same problem, there we go, there's our ice cream.
Yep.
And we see our midpoint formula. If you want to hit it one more time so we can see how the results come out.
Sure.
All right, so we can see, again, Q2 minus Q1
Yep.
over Q2 plus Q1 over 2, all that over the price one. You notice that our numbers are different, but not all that far off from when we did the ratio
Right,
method.
right.
And we come out with a decimal answer of 2.32.
So what we've seen here is that our coefficient, while close, clearly our last one wasn't
As accurate.
As accurate.
Right.
So what we have to think about now is what these coefficients mean. And so what PEOD here means, okay, is price elasticity of demand. And so when we look at the coefficient that we come up with, if it is less than 1, then our demand is going to be inelastic. Oh boy.
Now,
See if we can go back. I gotcha.
backspace.
No. Nope, doesn't want to work for us. We're doing so well,
We
too.
were. There we go.
Okay. All right.
Keep going. Keep
Here we
going.
go, kids.
Oh,
Oh.
right there.
Where am I? Right here? Yes.
There
Okay.
we go. So as Mr. Bandis was saying before everything,
Can't bring
went
me
down
any.
the toilet here.
Yeah.
All right. If the coefficient is less than 1, then the demand is going to be inelastic.
Right.
If it's greater than 1, demand is elastic.
Right.
If it equals 1, it is unit elastic.
Exactly. So really what this allows us to do is we can understand a whole range now. So for instance, if we're comparing curves or even segments on the same curve, and one part of the curve or one curve has, say, a PEOD of 2, and the other curve has a PEOD of 3, we know the second curve is more elastic than the first curve. And same for the inelastic. The closer this approaches to 0, the more inelastic that curve is. So what it really allows us to do is understand how consumers are going to react to changes in price. Right?
Sounds good.
So this last one, Mr. Sig, is a head scratcher.
It is a head scratcher, and I'm looking at it and I'm seeing a demand curve as it's supposed to be.
Right.
A curve.
Well, we notice it's downward sloping left to right,
That's right.
but it's not a nice, pretty straight line like
It's
we've been
not,
playing
which
with.
means it must have a much more complicated formula than what we've been letting out before.
Yeah, I agree, and I don't think we're going to torture you guys with this, but I would like you just to think about what this curve means in terms of elasticity. For instance, what do you think the elasticity is here versus here? Okay, and that's something that we're going to be looking at in the coming days.
Sounds good.
I think I'm feeling great.
I feel wonderful.
I'm going to go home and put on some elastic waisted pants.
There you go.
All
I'm going
right.
to go find another striped shirt.
Okay, Mr. Corsetti, it's been a pleasure as always.
Absolutely.
Now, get back to the west side.